Hello students. So last video dalli ನಾವು ಕೆಮಿಸ್ಟ್ರಿ KCET 2020 ಪೇಪರ್ಸ್ ಅಲ್ಲಿ ಇರುವಂತ ಕೆಲವೊಂದು ಕ್ವೆಶ್ಚನ್ಸ್ ಅನ್ನ ಸಾಲ್ವ್ ಮಾಡಿದ್ವಿ. ಸೊ ಹಾಗೆ ಇವತ್ತಿನ ವಿಡಿಯೋದಲ್ಲೂ ಕೂಡ ಅದನ್ನೇ ಕಂಟಿನ್ಯೂ ಮಾಡ್ತೀನಿ. ಸೊ ಫ್ರಮ್ ಕ್ವೆಶ್ಚನ್ ನಂಬರ್ 21. ಓಕೆ, ಸ್ಟಾರ್ಟ್ ಮಾಡೋದಕ್ಕಿಂತ ಮುಂಚೆ ಯಾರಾದರೂ ಇನ್ನೂ ನನ್ನ ಯೂಟ್ಯೂಬ್ ಚಾನಲ್ಗೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಆಗಿಲ್ಲ ಅಂತಂದ್ರೆ ಪ್ಲೀಸ್ ಸಬ್ಸ್ಕ್ರೈಬ್ ಆಗಿ, ಜೊತೆಗೆ ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ ಮತ್ತೆ ಸ್ಟೂಡೆಂಟ್ಸ್ ಗ್ರೂಪ್ಸ್ ಯಾವ್ದಾದ್ರು ಇತ್ತು ಅಂತಂದ್ರೆ ಅದಕ್ಕೆ ಚಾನಲ್ ಲಿಂಕ್ ಅನ್ನ ಶೇರ್ ಮಾಡಿ. ಸೊ ಕ್ವೆಶ್ಚನ್ ನಂಬರ್ 21, ವಿಚ್ ಆಫ್ ದ ಫಾಲೋಯಿಂಗ್ ಹ್ಯಾಸ್ ದ ಲೋಯೆಸ್ಟ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್? ಸೊ ನೀವು ಇದನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡ್ಬೋದು. ಸೊ ಹಿಯರ್ ವಿ ಹ್ಯಾವ್ ಡಿಫರೆಂಟ್ ಆರ್ಗ್ಯಾನಿಕ್ ಕಾಂಪೌಂಡ್ಸ್, like the first option we have alcohol CH3 CH2OH, and in the second option we have CH3 CH2 NH2, that is nothing but amine group, that is primary amine. And in the option C we have CH3OCH3, that is ether. And in option 4 we have HCOOH, that is carboxylic acid group. So if you consider all these functional groups, we can expect hydrogen bonding in option A, that is alcohol and amine group and carboxylic acid group, because we know that we can expect hydrogen bonding only when the hydrogen is directly bonded to either any of these more electronegative elements like fluorine, oxygen as well as nitrogen. But in case of this option C, we have ether. In this ether functional group, the oxygen is not directly attached to hydrogen, so that we cannot expect hydrogen bonding in case of ether. So if there is a presence of hydrogen bonding in any of the organic compound, probably its boiling point will be high. But in case of ether, we cannot expect hydrogen bonding, hence its boiling point is lowest among the given options. So for question number 21, it's option C. 22, the carbonyl compound that does not undergo aldol condensation is. So in the previous video, I have discussed the aldol condensation, especially that cross aldol condensation. So here one more question is based on the aldol condensation. We know that aldehydes and ketones that contains alpha hydrogen atom, aldehyde and ketone that contains alpha hydrogen atom will undergo aldol condensation. So there are different types of condensation reaction. If both the reactants are aldehyde, then it is aldol condensation. If both the reactants are ketones, then it is ketol condensation. If any two different aldehyde or any two different ketone, or one reactant is aldehyde and another reactant is ketone, then which is called as mixed aldol or cross aldol condensation. So for all these different types of condensation reaction, the aldehyde or ketone that must consist of alpha hydrogen atom. So here in this case, that option A, that is acetone, which is having the formula CH3COCH3. So here we have alpha hydrogen atom, so that it can exhibit aldol condensation. Dichloroacetaldehyde like CHCl2CH4. So here we have one alpha hydrogen atom, so that we can expect aldol condensation in dichloroacetaldehyde. Then if you consider option D, acetaldehyde, which is nothing but ethanol, CH3CH4. Here also we have 3 alpha hydrogen atom, we can expect aldol condensation. But if you consider trichloroacetaldehyde, which is CCl3CHO. So here there is no alpha hydrogen atom present in this trichloroacetaldehyde group, so that The carbonyl compound that does not undergo aldol condensation among the given option is trichloroacetaldehyde, option C. Then, so observe this a series of a reaction. Like first we have nitrobenzene. Nitrobenzene. So nitrobenzene on treating with bromine in presence of ferric bromide, so which is going to form P. Then which is on treating with Sn in concentrated HCl forms Q. Then on treating with NaNO2 in dilute HCl, which gives R. So we have to predict the final product R. So here we have a named reaction, series of named reactions. Nitrobenzene on bromination. This part is the first step in this series of reaction is bromination, which is going to form so metabromo nitrobenzene. Then again, which is on reduction. So the second step is nothing but reduction, which is going to form metabromo aniline and metabromo aniline on treating with the sodium nitrite in dilute HCl. The process is known as diazotization. Diazotization, which is going to form diazo compound like metabromo benzene diazonium chloride, which is on hydrolysis gives metabromophenol, which is the final product metabromophenol. So in that I have not given the option. So the option in that question paper is metabromophenol. Metabromophenol. Then question number 24. Hinsberg's reagent is. So ನೋಡಬಹುದು ಎಷ್ಟು ಡೈರೆಕ್ಟ್ ಕ್ವಶನ್ಸ್ ಅನ್ನ ಕೇಳಿರ್ತಾರೆ. ತುಂಬಾ ಸಿಂಪಲ್ ಇರುವಂತದ್ದು. ಹಿನ್ಸ್ಬರ್ಗ್ ರಿಯೇಜೆಂಟ್ ವಿಚ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ದ ಫಾರ್ಮುಲಾ C6H5SO2Cl ಅಂಡ್ ಇದರ ಕಾಮನ್ ನೇಮ್ ಬಂದು ಬೆನ್ಝೀನ್ ಸಲ್ಫೋನಿಲ್ ಕ್ಲೋರೈಡ್. ಬೆನ್ಝೀನ್ ಸಲ್ಫೋನಿಲ್ ಕ್ಲೋರೈಡ್. ಬೆನ್ಝೀನ್ ಸಲ್ಫೋನಿಲ್ ಕ್ಲೋರೈಡ್ ನ ಕಮರ್ಷಿಯಲ್ ನೇಮ್ ಆಗಿ ಹಿನ್ಸ್ಬರ್ಗ್ ರಿಯೇಜೆಂಟ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಅಂಡ್ ದಿಸ್ Hinsberg reagent, which is used to distinguish primary, secondary, and tertiary amines. So, theory part alle idana odirtira. Hinsberg reagent, which is used to distinguish the primary, secondary, and tertiary amines, and it is generally known as benzene sulfonyl chloride with the formula C6H5SO2Cl. That is option D. 25. Which one of the following vitamins is not stored in adipose tissue? So biomolecules chapter in the questions anna select madidare. So tumba easy idu kuda. We know that this adipose tissue anta ಏನು ಹೇಳ್ತಾರೆ, those vitamins. So adipose tissue ನಲ್ಲಿ ಯಾವ ತರ vitamins ಅನ್ನ ಸ್ಟೋರ್ ಮಾಡುತ್ತೆ ಅಂತಂದ್ರೆ, adipose tissue stores only those vitamins which are fat soluble. Only fat soluble vitamins are stored in adipose tissue. So ನಮಗೆ ಗೊತ್ತಿರೋ ಹಾಗೆ ಫ್ಯಾಟ್ ಸಾಲ್ಯುಬಲ್ vitamins ಬಂದು A, D, E and K. So among the given options A, D and E vitamins ಅನ್ನ ನಾವು ನೋಡಿದ್ದೇವೆ. ರಿಮೈನಿಂಗ್ ಇರುವಂತದ್ದು ವಿಟಮಿನ್ B6 and in this ವಿಟಮಿನ್ B6 ಅಂತ ಏನ್ ಹೇಳ್ತಾರೆ, which is water soluble actually. So vitamin B6 ಬಂದು water soluble ಆಗಿರೋದ್ರಿಂದ which is not stored in adipose tissue. So remember one thing, in adipose tissue only those vitamins are stored in which they are fat soluble. Example A, D, E, K. So question, which one of the following vitamins is not stored in adipose tissue ಅಂತ ಹೇಳಿದ್ರೆ, which is option B, vitamin B6. 26. Hypothyroidism is caused by the deficiency of. So ಈಸಿಯಾಗಿ ಪ್ರೆಡಿಕ್ಟ್ ಮಾಡುವಂತ ಕ್ವಶನ್ ಇದು. ಸೊ hypothyroidism which is caused by the deficiency of thyroxine. And what is meant by thyroxine? The hormone produced which is a hormone produced in thyroid gland. ಸೊ ಥೈರಾಯ್ಡ್ ಗ್ಲ್ಯಾಂಡ್ ಅಲ್ಲಿ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುವಂತ ಹಾರ್ಮೋನ್ ಥೈರಾಕ್ಸಿನ್ ಡಿಫಿಷಿಯನ್ಸಿ ಆಯ್ತು ಅಂತಂದ್ರೆ ಸೊ ಹೈಪೋಥೈರಾಯ್ಡಿಸಮ್ ಅನ್ನೋ ಒಂದು ಸಿಂಪ್ಟಮ್ಸ್ ಅನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡಬಹುದು. ಸೊ ದಟ್ ಫಾರ್ ಕ್ವೆಶ್ಚನ್ ನಂಬರ್ 26 ಇಟ್ಸ್ ಆಪ್ಷನ್ ಸಿ. 27 C1C4 glycosidic bond is not found in. So we know that if you consider sucrose, we have C1 and C2 glycosidic bond or glycosidic linkage, but not C1C4. ರಿಮೈನಿಂಗ್ ನೀವು ಯಾವುದೇ ಆಪ್ಷನ್ಸ್ ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರು ಲ್ಯಾಕ್ಟೋಸ್, ಸ್ಟಾರ್ಚ್, ಮಾಲ್ಟೋಸ್ ಈ ಒಂದು ಬಯೋಮಾಲಿಕ್ಯೂಲ್ಸ್ ನಲ್ಲಿ ಅಥವಾ ಪಾಲಿಸ್ಯಾಕ್ರೈಡ್ಸ್ ಅಥವಾ ಮೊನೋಸ್ಯಾಕ್ರೈಡ್ಸ್, ಡೈಸ್ಯಾಕ್ರೈಡ್ಸ್ ಏನಂತ ಹೇಳ್ತಾರೆ, ಡೈಸ್ಯಾಕ್ರೈಡ್ಸ್ ಅಥವಾ ಪಾಲಿಸ್ಯಾಕ್ರೈಡ್ಸ್ ಅಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ನಮಗೆ C1C4 ಗ್ಲೈಕೋಸಿಡಿಕ್ ಲಿಂಕೇಜ್ ಅನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀವಿ. ಜನರಲಿ ವಿ ಕ್ಯಾನ್ ಕಾಲ್ ಇಟ್ ಆಸ್ ಆಲಿಗೋಸ್ಯಾಕ್ರೈಡ್ಸ್. So for question number 27, it's option D. C1C4 glycosidic bond is not found in sucrose because it is having C1C2 glycosidic linkage. 28. Which of the following polymers has the strongest intermolecular forces of attraction? So given options are polythene, polystyrene, neoprene and terylene. So ಏನ್ ಪಾಲಿಮರ್ಸ್ ಇಂದ ಕ್ವಶನ್ಸ್ ಅನ್ನ ಆಫ್ ಮಾಡಿದ್ದಾರೆ, ಇದು ಕೂಡ ಡೈರೆಕ್ಟ್ ಆಗಿ ಪ್ರೆಡಿಕ್ಟ್ ಮಾಡುವಂತ ಕ್ವಶನ್. ಯಾಕೆಂದ್ರೆ ವಿ ನೋ ದಟ್ ಪಾಲಿಥೀನ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ದ monomeric unit. So we'll write a monomer here. So polythene is having the monomer. We know that it's ethene, which is having the formula C2H4. And polystyrene. So ಕೆಲವೊಂದೆಲ್ಲ ಪಾಲಿಮರ್ಸ್ ಗೆ we can easily predict the monomer by removing the term poly. So its monomer unit is styrene, which is having the formula C6H5CHCH2. Then neoprene, its monomeric unit is chloroprene, having the formula CH2 double bond CCl CH double bond CH2. So this is a chloroprene. Then terylene, we have one more polymer terylene, which is having two different monomeric units. 1,4 benzene dicarboxylic acid. It's one of the monomeric unit, and the second one is 1,2 ethane diol. So these are the two monomeric units of terylene, and which is having the strongest intermolecular hydrogen bonding. So we can expect hydrogen bonding between these two monomeric units, and which is strongest among the other options like polythene, polystyrene and neoprene. So that for question number 28 is option D. 29. Which of the following monomers can undergo condensation polymer? Okay. Given options are isoprene, propene, styrene as well as glycine. So here we can observe option D, that is glycine, which can undergo condensation polymerization. So students, ನಿಮಗೆ ಗೊತ್ತಿರಬಹುದು condensation. The term condensation refers to the combination of two or more substance by eliminating the smaller molecules like water, ammonia, HCl, etc. So ಯಾವುದೇ ಒಂದು ಅಡಿಷನ್ ರಿಯಾಕ್ಷನ್ ಅಲ್ಲಿ, ಅಡಿಷನ್ ಮೀನ್ಸ್ ಕಾಂಬಿನೇಷನ್ ರಿಯಾಕ್ಷನ್ ಅಲ್ಲಿ, ಅಡಿಷನ್ ಅಂತ ಹೇಳಿದ್ರೆ ತಪ್ಪಾಗುತ್ತೆ ಬಿಕಾಸ್ ಪಾಲಿಮರೈಸೇಷನ್ ಅಲ್ಲಿ ವಿ ಹ್ಯಾವ್ ಟೂ ಟೈಪ್ಸ್ ಆಫ್ ಪಾಲಿಮರೈಸೇಷನ್. ಒನ್ ಈಸ್ ಅಡಿಷನ್, another one is condensation polymerization. So condensation polymerization in the sense a combination of two monomeric unit anta helbodu. So a combination time alli, okay, here we can observe hydrogen, two hydrogen atoms that is attached to nitrogen of one glycine is going to form bond with oxygen that is present in alcoholic functional group, hydroxyl functional group or carboxylic functional group of another glycine molecule. So that which is going to liberate a smaller molecules like water. And this type of reaction is known as condensation polymerization. So for question number 29, it's option D. 30. A food additive that also acts as an antioxidant is. So given options are sugar syrup, then salt, BHA, and saccharin. So we know that saccharin acts as artificial sweetening agent. And here a food additive that also acts as antioxidant is BHA. So BHA anta helidre butylated. So abbreviation helodadre butylated hydroxyl anisole. So BHA in the sense butylated hydroxyl anisole anta ಹೇಳ್ತಾರೆ, which acts as an antioxidant in foods to stop the food from getting oxidized and preventing them from going rancid. ಹಾಳಾಗೋದನ್ನ ತಡೆಯೋದಕ್ಕೆ ಸೊ ಆಂಟಿ ಆಕ್ಸಿಡೆಂಟ್ ಆಗಿ ಆಕ್ಟ್ ಮಾಡುತ್ತೆ. ಸೊ ಎಕ್ಸಾಂಪಲ್ಸ್ ಹೇಳೋದಾದ್ರೆ 2 tertiary butyl 4 hydroxy anisole, 3 tertiary butyl 4 hydroxy anisole. These are some of the examples for butylated hydroxyl anisole, BHA. Then 31. Which of the following is not related to drug enzyme interaction? So drug enzyme interaction alli yavdu relate agilla anta helta idare, which is antagonist. It's option D. So we know that antagonist impede the action of drugs by occupying the enzyme sites themselves, and hence is the odd out of the remaining options. Then question number 32. 0.4 gram of dihydrogen is made to react with 7.1 gram of dichloride to form hydrogen chloride. The volume of hydrogen chloride formed at 273 Kelvin and 1 bar pressure is. So first ನಾವು balanced chemical equation ಅನ್ನು ಬರ್ಕೊಳ್ಳೋಣ. They are given dihydrogen reacts with dichloride to give HCl. So this is the balanced chemical equation. So it is going to form 2 moles of HCl. Then according to the question, if 0.4 gram of dihydrogen is reacts with, okay, let me calculate the mole of dihydrogen. So it's 0.4 divided by its molar mass of hydrogen is 2. So 0.4 by 2, which gives 0.2 mole. Then we can calculate the mass of dihydrogen. Mass of dihydrogen is the, okay, wait, first we will calculate the limiting reagent among hydrogen and oxygen. So dichloride given is 7.1 gram. Okay, I've told oxygen, it's not oxygen, it's chloride. So 7.1 gram of dichloride they have given. So 7.1 divided by the molar mass of chlorine molecule is 71 only. So it gives 0.1 mole. Okay, here according to the balanced chemical equation, to form 2 moles of dihydrogen chloride, we need 1 mole of dihydrogen and 1 mole of dichlorine. So here they have changed the molar ratio of dihydrogen and chlorine. So according to the molar ratio, what they have given, chlorine acts as limiting reagent. So if chlorine acts as limiting reagent, means hydrogen acts as an excess reagent. And we know that amount of product always depends on the limiting reagent. Amount of product always depends on limiting reagent. And here in this question, chlorine is the limiting reagent. So that if 1 mole of chlorine gives 2 moles of HCl according to the balanced chemical equation. Therefore, they have given 0.1 mole. 0.1 mole of chlorine gives. So we have to do the cross multiplication like 2 into 0.1 divided by 1. So which gives 0.2 mole of HCl. So what's the number of moles formed in HCl is 0.2 mole of HCl. Okay, now we have to find out the volume of HCl. So assume the volume of HCl formed in STP condition is. So I will remove this part because I have to do some more steps. So change the ink. Okay, here we have, so 1 mole of gas in STP occupies, that is gas that refers to HCl. So at STP, 1 mole of gas occupies 22.7 liter, that we know that. Therefore, so number of moles of HCl liberated is 0.2 mole. 0.2 mole of gas in STP occupies, cross multiplication again, 22.7 into 0.1, sorry 0.2 divided by 1. So which gives 4.54 liter of HCl. That is option D, 4.54 liter. Then 33. With regard to photoelectric effect, identify the correct statement among the following. So energy of electron ejected increases with increase in the intensity of incident light. Number of electrons ejected increases with increase in the frequency of incident light. Number of electrons ejected increases with increase in work function. Number of electrons ejected increases with increase in intensity of incident radiation or light. Okay, this question is based on, as they have mentioned, it is based on photoelectric effect. Okay, so already they have given the concept photoelectric effect. Let me consider the photoelectric effect and its condition. What are the important properties of photoelectric effect? So which is generally explained in theory itself. Okay, let me consider. If we consider energy of photoelectron, energy of photoelectron is nothing but electrons emitted from the metallic surface during the photoelectric effect. So energy of photoelectron increases with increase in frequency of light. So energy of photoelectron increases with the increase in frequency of light, which means energy of photon depends on frequency of incident radiation. But if you consider number of photoelectrons ejected, that increases with increase in intensity of incident radiation or intensity of incident light. So that for question number 33, it's option B. Number of electrons ejected increases with increase in intensity of incident light or incident radiation. And here intensity also refers to amplitude, that is height of crest or depth of trough. Then 34. The last element of the P block in sixth period is represented by the outermost electronic configuration. So students, you have to remember some elements that is present in a particular group. So let me consider 18 group. In last element means 18 group in P block, which is P block elements are present in 13th to those 18th group. Last element means that is present in 18th group only. So in sixth period, we know that outer electronic configuration of p block is ns2np126. So that if you consider the outermost shell, here they have mentioned the outermost shell is sixth shell. So that n is nothing but outermost shell or valence shell. So the electron must be present in sixth p orbital only, and which is the last element present in p block in sixth period, that is radon, which is a noble gas having the symbol R10, and which is having the electronic configuration noble gas core, that is xenon, then 4f14, 5d10, then 6s2, and 6p6. Then which is the correct option? It's option B. So they have mentioned just the outermost electronic configuration: 4f14, 5d10, 6s2, and 6p6. Then 35. The conjugate base of NH3 is. We know that conjugate base and acid are differ by only one proton. So a conjugate base has one proton less from the acid. So if you remove one hydrogen from NH3, so which gives NH2 minus. That is option B, NH2 minus. 36. A gas mixture contains a 25% helium and 75% methane by volume at a given temperature and pressure. The percentage by mass of methane in the mixture is approximately. So let me consider. Here they have mentioned, since temperature and pressure are constant, T and P are constant. So we can assume it to be in STP condition, standard temperature and pressure condition. So let the volume be 100 liters. And can we calculate moles of helium and moles of CH4? So moles of helium present is, moles means 25%, they have given 25 divided by 22.4. So which gives 1.12 mole of helium. Then after that we can find out mass of helium. So mass is 1.12 number of moles into its molar mass, that is 4. It is 4.48 gram. This is the mass of helium. Then if we consider moles of methane, that is CH4. So we have to take the ratio like 75% of methane they have given, 75 divided by 22.4, which gives 3.35 mole. Okay, then we can find out mass of methane. So that is product of number of moles into its molar mass, that is 16. So which gives 53.60 gram of methane. Now we have a formula to find out percentage mass. So the mass percentage of methane, which is mass of methane 53.60 divided by total mass of the solution, is 53.60 plus 4.48, which gives 58.08, and we are calculating percentage, hence it is multiplied by 100, which gives 92.28%. 92.28%, which is almost equivalent to option C. Then 37. The percentage of S character in the hybrid orbitals of nitrogen in NO2 plus, NO3 minus, and NH4 plus respectively are. Okay. If you consider NO2 plus, the central atom nitrogen has 2 sigma bonds, which consists of 2 sigma bonds. Hence, it is sp hybridized. sp hybridized. sp hybridized means a percentage of S character, which is equal to half, because there are only 2 orbitals are there, half into 100, which is 50%. Similarly, if you consider NO3 minus, central atom nitrogen has 3 sigma bonds. 3 sigma bonds means it is sp2 hybridized. So sp2 hybridized means a percentage of s character will be, so 1 by 3 into 100. 3 orbitals are there, so that 1 by 3 into 100, that gives 33.33%. Then the last molecule NH4 plus, in that central atom nitrogen, which has 4 sigma bond. 4 sigma bond. 4 sigma bond means which undergoes sp3 hybridization, and percentage of s character in sp3 hybridization is 4 orbitals in sp3 into 100, which gives 25%. So the percentage of s character is 50%, 33.33 and 25% respectively. That is option A, 50, 33.3 and 25%. Then 38, the formal charge on central oxygen atom in ozone is. So here is the structure of ozone. So we have 3 oxygen atoms with, we'll consider central atom as oxygen 1, and oxygen present at the left side is oxygen 2, and the right side as oxygen 3. And we have the formula to find out formal charge. Formal charge, which is equal to number of valence electron. Number of valence electron in neutral atom minus half into number of valence electron in covalent bond, which is nothing but number of bonded pair of electron, again minus number of electrons in lone pair. Okay, if you consider the central oxygen atom, so if you consider any oxygen atom, number of valence electron in neutral oxygen atom is 6 minus half into number of valence electron in covalent bond. Covalent bond means how many electrons are involved in this covalent bond. There are 3 bonds, that is with respect to central oxygen atom. So that 3 bond is equivalent to 6 electron, half into 6 minus number of electrons in lone pair. So we have only one lone pair present on the central oxygen atom. So that number of electrons will be 2. So 6 minus half into 6 means 3, 3 minus 2. 6 minus 3 minus 2, which is equal to plus 1, which is the formal charge on central oxygen atom. That is option D. 39. When the same quantity of heat is absorbed by a system at 2 different temperatures, T1 and T2, such that T1 should be greater than T2, then change in entropies are delta S1 and delta S2 respectively. Then what is the correct relationship between change in entropies? Okay, we know that in thermodynamics we are concerned about the entropy change, which is characterized by the symbol delta S, entropy change. What is entropy? It's the measure of randomness or disorderness of a system. And due to the transfer of heat, so delta S can be taken as the ratio of Q divided by T. And we know that Q is a constant. Generally, it is called as heat constant. And if you remove the constant, the equation becomes delta S inversely proportional to temperature. Okay, if delta S is inversely proportional to temperature and they have given the relationship between temperature, that is T1 greater than T, then you can predict the answer. Delta S1 is less than delta S2. So this is the relationship between change in entropy. It is option C, delta S1 less than delta S2. 40. The oxidation number of nitrogen atoms in NH4NO3 are. So we know that NH4NO3 is a salt which consists of 2 parts. If you consider cationic part, so in any ionic compound or salt, first we will write cation. So that cationic part is NH4 plus. Let me consider the oxidation number of nitrogen in NH4 plus first. Consider N as X plus, there are 4 hydrogen atoms attached to nitrogen, so that's 4. and the charge on cation is 1, so that plus 1. X plus 4, which is equal to plus 1, therefore x is equal to minus 3. Similarly, we have one more part, that is anionic part. Anionic part is NO3 minus. So here nitrogen as X minus, because the oxidation state of oxygen is minus 2. Minus 2 into 3, which is minus 6. And the charge on anion is minus 1. X minus 6, which is equal to minus 1. Therefore, X is equal to plus 5. So these are the oxidation number of nitrogen atoms in NH4 and NO3. That is minus 3 and plus 5 respectively. Then what is the correct option? It's option D. So students, remaining ಇರುವಂತ 20 questions ಸೊ ನೆಕ್ಸ್ಟ್ ವಿಡಿಯೋದಲ್ಲಿ ಸಾಲ್ವ್ ಮಾಡೋಣ. ಸೊ ಈ ವಿಡಿಯೋ ನಿಮಗೆ ಇಷ್ಟ ಆಗಿತ್ತು ಅಂತಂದ್ರೆ ಪ್ಲೀಸ್ ಲೈಕ್ ದ ವಿಡಿಯೋ ಅಂಡ್ ಶೇರ್ ಇಟ್ ವಿತ್ ಯುವರ್ ಫ್ರೆಂಡ್ಸ್, and please do subscribe the channel. Thanks for watching.